Good morning everyone, this is Vrushali. In our last session, we discussed about classification, regression, probability, then a bias theorem and clustering algorithms with example. I have mentioned machine learning playlist link in below description box. Now in this session, I am going to present the next topic, that is association rule mining and a priori algorithm. So let's see. In this session, we will discuss about association rule, their working, their evaluation, a priori algorithm, their steps, working example, applications, and advantages and disadvantages. So let's see one by one. The first point is association rule learning. So basically, this association rule learning is a type of unsupervised learning technique because it's work on random data set. So here let's take one example. The best example of association rule is market basket analysis. Like in any shopping malls or in any mart where suppose a customer buy a bread, then they also buy a butter, eggs or milk like this. So these every things that purchased together are put together, right? For example, customer 1 they buy milk, bread, butter. Then second customer they also buy milk, bread, butter and other related things, right? So this is called as association rule. Means suppose person buy a milk, then they also buy a bread. So this concept is called as association concept. So in this association rule, it dependency of one data item on another data item, it check that. That's why these all things are put together in any particular supermarket. So it find the super interesting relation among the different kind of data set. That's why these association rules are used. Next. The next concept is how does association rule learning work? So basically association rule is based on if-else statement. For example, if particular person buy A, then they also buy a B in this way. For example, see here, if a particular person buy a laptop, then they also buy a bag. So this is called as one kind of association rule. Here this if element is called as antecedent and this then element is called as consequent. And this complete relationship is called as single cardinality. And that's why this kind of rules are used in different supermarkets and these things are more profitable. So another again example is there, if particular customer buy bread, then they also buy a jam, right? So these all things are put together. And this is called as association rules. Next. So next point is association rules evaluation. So these association rules are calculated by using two concepts. One is support, another one is confidence. When we will execute a particular problem statement, at that time in this a priori algorithm, this support and confidence, these two concepts are used for solving the example. The first one is support. What exactly support? Support means how frequently an items are appear in dataset. For example, person A buy milk, then person B they also buy milk and butter, right? So these two transactions, how many times milks are present? 2 times. So this is called as support. Means milk, how many times milks are purchased? So this concept is called as support. Means the frequency of particular buying item upon transaction. So this is called as support. Next one is confidence. So confidence is related to the how many times a particular items are bring together or purchased together. For example, item X and Y. So this X and Y, these both items are occur together. This is called as confidence. They check how many times the frequency of that particular purchasing item. So these two terms are used while solving the example. Support, how many times a particular items are purchased, single item. And confidence, how many times two items are purchased together. So this is called as confidence. So we will use this formula for solving the example. The next point is a priori algorithm in machine learning. So a priori algorithm generally used to calculate the association rules by using support and confidence. So this algorithm was developed by R. Agrawal and Srikanth in the year of 1994. So basically a priori algorithm is used to calculate the frequent item sets in this market basket analysis. So what exactly frequent by item set? See here in this term. Suppose there are two transactions. Person A purchase 1, 2, 3, 4, 5 items and person B purchase 2, 3, 7 items, right? So this both person purchased common item, that is 2 and 3, right? So this is called as frequent item sets. So the items which purchase commonly by using different transactions or different persons. So this is called as frequent item sets. So this a priori algorithm generates or determine how strongly and how weakly two objects are connected. For example, person buy milk and bread. So majority of that persons are more. This is called as strongly connection between these two rules. And if a particular thing, for example, there is a milk and there is a laptop, so these two kind of items not purchased together, so this is called as weakly connected, right? So that's why these a priori algorithms are used. They check that whether the strong relation is there between these two item sets or weak relation is there. So that's why these algorithms are used, and this algorithm generally used in different market basket analysis. It helps to find those products that can be bought together. So let's see. So these are the steps of a priori algorithm. I will explain these steps with example. Okay. So just review the steps. In step 1, you need to calculate the support value as per your given data set. In second step, you need to calculate their confidence value or highest support value. In third step, you need to find out the association rules. And in step 4, you need to sort the rules. So I will explain these steps with example now. Okay, so just see here, this is a priori algorithm working example. Now this is your given data set. Okay, this is your transaction ID and this is a item set. For example, the person 1, okay, or person A, this is your T1 transaction. So this person buy A and B item together. Second person, that is transaction 2, they buy B and D item. Transaction 3 means person 3 buy B and C item in this way. Okay, so how many persons are there? There are total 9 persons, mean 9 transactions are there, right? And these are the buying items or purchasing items. Now here in your problem statement, support and confidence values are given. Minimum support is equal to 2 and minimum confidence is equal to 50%. This is your given items. Okay, so you need to find out which is the best relationship or best association rule for purchasing the items. This is your problem statement. So next. Okay. Now the first step is you need to calculate C1 and L1. So what exactly it is? C1 means candidate set and L1 means frequent item set. Let's see here. Suppose this is your given data set. Okay. How many items are there? Total 5 items. A, B, C, D and E. Total 5 items are there. Okay. See here. This is your C1 table. There are 2 columns, item set and support count. You need to calculate support count in C1. So item sets are A, B, C, D, E. Total 5 item sets are there. Now how many times A item is purchased? So 1, 2, 3, 4, 5 and 6. So A items are purchased 6 times. Similarly B items are purchased 7 times. C items are have purchased 5 times in this way. So this is item sets and this is support count. Support count means how many times a particular items have purchased, right? So this is your C1 table. Now in L1 table. So in L1 table, in your given data set, minimum support is 2. So as per your this C1 table, see here, which is minimum support is 2, 2, 5, 7 and 6. Means 2 or more than 2, right? Minimum support is 2. So you need to remove this item in your data set, that is E and support count 1. Okay. So after applying minimum support 2, it generate the L1 table. See here, remaining items are as it is. Just remove this thing because this is not suitable to your given statement because minimum support is equal to 2 only, right? So this is your L1 table. Clear? Next. In step 2, you need to calculate C2 and L2 value. Okay. Now what exactly C2? See here. So for C2, you required your previous L1 table in step 1. Okay. See here, this is your previous table. Now you need to calculate how many times items are purchased together. For example, the relations between this. For example, A and B items together, B and C items are together. See here. First A to B, A to C, A to D. Then B to C, B to D and C to D. So you need to mention relation, 2 items relation between that. Okay. And now calculate how many times these items are purchased together. For example, A and B. So A and B items are purchased together 1, 2, 3 and 4 times in your given data set. Similar remaining items are purchased in this particular time. Okay, this is your C2 table. Now again your minimum support is 2, right? So according to this C2 table, you need to just take minimum support is 2, means 2 or more than 2. So for this relation, AD equal to 1 support count, this item purchase only one time, and CD equal to 0, this item purchase 0 time. So you need to remove this thing because minimum support is 2, and just take remaining items as it is. So this is your L2 table. Okay, next. Right. The next point is calculate C3 and L3. Now 3 means 3 items purchased together. Okay. Now this is your previous table, L2 table in step 2. So according to this table, you need to generate this C3 table. Okay. So see here. First relation, 3 relations together, A, B, C. Next B, C, D. Next again A, C, D and A, B, D. So these 4 relations or 4 item sets are generated here. Right. Now just check that these item sets in your given data set. How many times A, B and C, these items are purchased together? See here, A, B, C and A, B, C. Means these items are purchased together 2 times. Right. Now check B, C, D. So B, C, D, where is B, C, D? So see here, B, C and D. So these items are purchased together only one time. Right. And remaining A, C, D and A, B, D, these items purchased together 0 times. Clear? Now again check that your minimum support is 2. So minimum support is 2 is here, and remaining below 2, that is 1, 0, 0. You need to remove these items. Okay. So in L3 table only one item set is there, A, B, C is equal to 2. Okay. So this is your only one combination, means item A, B and C. These items are frequently buy together. Okay. Next. Now in step 4, you need to find out the association rules of the subset. In step 1, 2 and 3, you just use support formula, right? You calculate the support of each and every items and the relations of each and every items. Now in this step 4, you need to calculate association rules. So as per your previous step, A, B and C, as per your L3 table, these combinations are generated. Okay. Now you need to calculate the association rules between this A, B and C. So for that purpose, you need to use confidence formula, and confidence formula is this: support A raised to B upon A. This is a formula of confidence, and in your given data set, minimum confidence value is 50%. So let's see the next. Right. Now see here, this is the step, your step 4. So in step 4, you need to generate this table. Okay. The first is rules, second one is support, and third one is confidence. So here rules and support, these items are already generated in step 1, 2 and 3. Now see here. So as per your given relation previously, A, B and C, this is your given relation, right? As per your L3 table, these 3 items are frequently buy together. Now just make a relationship between these 3 items. See here, these are the association rules. For example, AB to C, next BC to A, see here, next AC to B. Next rule is C to A to B, then BA to B to C and B to B to C. So these 6 rules are generated as per this given item set, right? From this 3 item set, 6 rules are generated. And now let's check their support count is here. For example, ABC. So ABC support count is 2 is here. Now BCA again same, BCA support count is 2, and in this way the complete item set support count is 2 because this item purchased 2 times. So that's why the support counts are 2. Now next one is confidence formula. See here, rule divided by LHS. So the first you need to calculate confidence of this rule. How to calculate? See here, support, and mention these rules are there. Support A to B to C. So you need to mention this rule divided by LHS or A. So your LHS is this, support A to B. This is your LHS, this is your RHS, right? LHS to RHS. So mention divided by LHS. So that is support A to B. So just see here, what is the support of ABC? Support of ABC is 2. So 2 divided by support of AB, and support of AB is 4. So 2 by 4, 0.5, it is 50%. 50% chances are there when person buy A and B item, then they buy C item also. So 50% chances are there. Now next, B, C and A. Again same, support of BCA divided by support of LHS, support of BC. So BCA support count is 2 divided by support of BC is 4. So 2 by 4, again 50%. So in this way you need to calculate the confidence formula up to last of every rules. Now in your given data set, minimum confidence is 50%. So check here, minimum confidence is 50%. Means rule 1, rule 2 and rule 3. These 3 rules having minimum 50% confidence are there. Right? So these are the strong association rules. You need to remove these 3 rules because that is minimum or 15%, not a minimum 50%. Right? So just focus on these 3 rules, because minimum confidence is 50% as per your given data set. So when person buy A and B item, then they buy C. When person buy B and C item, then they buy A. And when person buy A and C item, then they buy B also. So these are the strong association rules. In this way, a priori algorithms are used to calculate the association rules in market basket analysis purpose. Now next, applications of association rules. So as we discussed, market basket analysis is one of the best example of association rules, and with this thing which is commonly used in big retailers, in big supermarkets, to determine the association between items, because this most purchase items are frequently item purchased together, that put together. Next, medical diagnosis for identifying the probability of illness for particular disease. So these are the applications. Advantages and disadvantages. The advantages of a priori algorithm is very easy to understand and easily implemented on the large data set. And the disadvantages are, this a priori algorithm is slow as compared to other algorithms, and it scans the database for multiple times for calculating the support values, right? Means how many times a particular items are purchased. Next, time complexity and space complexity high sometimes as depend on data set. That's why these algorithms are used in your project as per the requirement. Keep learning, keep practicing.